Good day, and continuing our experiments with electricity and magnetism, today I thought we would do magnetic brakes. Now, magnetic brakes are used sometimes in amusement park rides. They could be used in other places. The neat thing about magnetic brakes is that you can generate a braking action without wearing the brakes out. There's no physical wear involved in the brakes. Now, maybe the bad thing about them is that they can't actually bring something to a complete halt. Well, maybe they can sort of, but they have a problem doing that. So you might usually combine magnetic brakes with more traditional friction types of brakes if you use them at all. Now, to explain this, let me go back to this concept that I've mentioned before, and that the only way that we generate a magnetic field is by having moving charge, and most of the time that means electric current. Well, it turns out that the physics that relates electric current and magnetic fields is such that we can also generate electric current by having moving magnetic fields, which is how a generator works. In fact, a motor, which is something which converts, which uses electric current to generate a magnetic field, and it uses the attraction and repulsion of magnets to generate the rotating action of a motor, can be turned into a generator because of the effect that a moving magnetic field can also generate an electric current. So let me demonstrate that. Now, in order to demonstrate that concept and to demonstrate the concept of a magnetic brake, what I'm going to use, I have a couple of really simple things here to show. I have a piece of copper plumbing here that I've purchased from Home Depot. It's about 5 feet long. It's just an ordinary piece of copper plumbing. I have a little chromium steel ball. It's not important what the material is here, because I'm only going to use this to drop it through the tube, the copper tube, to show you how fast it takes gravity to pull something through the tube. It's the only thing this is for. I could use something else. I could drop a screw or a nail or a frozen pea or anything through there to demonstrate that. Now, the other thing, the important thing here is that I have a rare earth disk magnet. Now, the rare earth disk magnets are very, very, very strong magnets, and that's very useful on this experiment. Now, as you may know, but in case you don't, that copper is not a magnetic material, and that the magnets don't stick to copper. Okay, it just won't stick to copper. Magnets will stick to lots of things. They'll stick to this steel ball, for instance, but it won't stick to the copper. Because the reason why I'm telling you that is because when I drop the magnet through this copper tube, it's going to be a slow drop through the tube. And I don't want you to think that the drop is a slow drop because the magnet is somehow sticking to the copper due to the magnetic field. That doesn't happen at all. What actually happens when the magnet drops through the tube is you have this moving magnetic field. The moving magnetic field generates an electric current that goes in the copper tube. As the electric current moves through this copper tube, it will generate, remember the electric current is moving charge, it will generate a counter magnetic field. So we have the magnetic field from the magnet, we have the magnetic field now generated by the electric current in the copper tube, and that electric current will slow down very, very much. It will slow down the fall of the magnet through the copper tube. So that's basically how these magnetic brakes work. We get some very, very strong magnets located very close to a conducting material, say usually copper, and as these very strong magnets move close to the copper. They generate electric currents in the copper. Those electric currents generate a magnetic field that opposes the magnetic field of the permanent magnets. That's what causes the braking action. That's what slows this all down. So, to illustrate that, I'm going to use rare earth disc magnet, small one about the size of a dime, a little metal ball, and a copper tube. So let's see how this works. Okay, I have here my copper pipe. It's a 1/2 inch diameter, copper plumbing. I bought it from Home Depot myself. Copper, as you might know, copper is not magnetic material in that it doesn't magnetize, and if you have a magnet it won't stick to copper. Now what I want to do, though, is to show you this basic principle of how magnetic brakes work. Now, what I'm going to do is drop 2 steel items, actually 1 steel item and 1 magnet, down this copper pipe. I have a chromium steel ball right here. I'm going to drop this down the pipe, and then I also have my 1/2 inch, or not quite 1/2 inch in diameter, rare earth disc magnet that I'm also going to drop. Now, first the chromium steel ball, I'll drop it down and see how quickly it will fall down through the copper pipe. So here we go. Okay, so that's pretty fast. It's almost the same speed that it would fall if I had just dropped it next to the pipe, like this. Okay. If it's a little bit slower, it's because it touches the sides of the pipe on the way down, generating a little bit of friction. Now I'm going to drop this rare earth disc magnet down in through the copper pipe. The disc magnet is 7/16 of an inch in diameter, so it's smaller than the 1/2 inch diameter of the copper pipe. Now, copper is not magnetic. The magnet doesn't stick to the copper. But what does happen is that as the magnet moves, as it falls, the magnetic field of the magnet also moves. The moving magnetic field generates electric current in the copper walls of the pipe. That electric current in the copper walls in turn generates another magnetic field. That magnetic field will slow down. It interacts with the magnetic field of the magnet itself, slowing down its fall through the copper pipe. And the result is you get a braking action. Now, so as I drop this down, I want you to compare the difference between how long it takes the magnet to fall with how long it took the chromium steel ball to fall. Now get out your stopwatches, because you want to be able to measure the fact that there is a difference. So you might need stopwatches to tell the difference. Okay, now remember that the ball fell almost as quickly as you would expect it to fall if it were just falling in free space. So here's the magnet. I'm going to drop it in. Get ready. Here goes. So I hope you had your stopwatches to tell the difference. One more time. Ready, steel ball. Now stopwatches, magnet. It works. Well, that's our science lesson for today. I hope to see you again soon, where we'll do another great experiment.